Okay, let us see this case when we have minimum speed. I think you can see here, the one is minimum speed. We have seen the case for maximum speed. Now let us see this one for minimum speed. So a car of mass 700 kilograms moves with a constant speed v round a bent track. Around the bend, the track is bent at 45 degrees to the horizontal and the car moves in a circular path of radius 15 meters. If the coefficient of friction between the road and the surface and the car is 0.4 and the tires of the car can slip sideways on the track if moving at the minimum speed of, now it's not here, they are telling us minimum speed. Minimum speed means frictional force is going to act upwards. So find the reaction between the car friction force V and then the angular speed in rev per minute. This one, be careful. Okay, so start with a simple sketch. This is going to be my sketch now. Now I'm having a car is moving. There, that's our main truck. We are having a car here. Its mass is 700 kilograms. Of course, there is going to be reaction between, because there is contact between the car and the surface. Then we are going to be having the weight acting, which we get the mass times V. Then we are going to have the at 45 degrees to the horizontal. Now, because it's moving in a circular path, we are going to have our center somewhere there of the circular path from here, from that car. And then that center, they are telling us that it's 50 meters. The radius from here up to here is 50 meters up to there. Okay, so you have that. Now, our friction this time is going to act upwards like that. Our frictional force is going to act in that direction like that. Or you can put there F. It's up to you. Either you put it here as F, it's up to you, or you put it like that. Now, so basically that's what we have. Our task is now to resolve that thing into horizontal and then a vertical component for that. So we have everything now. Here, I think you can see if I draw this simple diagram there, this is the horizontal, this is what we have, and this is the force we have, the center C there. So we have our R there, and then we have our force in that direction, the frictional force. Now, from here, I think you can see if this is 45, then this is going to be 45 degrees also, 45 degrees. And you say this is always, the reaction is always perpendicular to the surface. So this is 45, it means that also this one here is going to be 45, 90 minus 45. Then this one here, I think you can see if I do this. So remember this is 90. So always, this first of all is 45, imply that even this one is going to be 45 there. So after doing that, then we come and we focus on this R, the reaction here. So this is going to be our reaction in this order. That is our R. Then this horizontal here, I think you've seen it there. The horizontal here, this one, I think you can see that angle is 45. If this is 30, this will be 30, this will be 60. As you pass that, this is 60, if this is 20, this will be 20, this will be now 70. It's like that, simple. I'm just using 45 for, for my reasons. So this is going to be 45 degrees. Now, if you resolve this force, this is going to be the horizontal component, which is going to be R. You see this is adjacent, and adjacent goes with the cos. So cos 45. Then this one is going to be now, we go like this, then to the force. So this is going to be now opposite to this angle, which I can write this side also. So this is going to be now R sine 45 degrees. So now I'm done with drawing this. Now when I come to this force, I think we can see that force is that direction. This is our frictional force. Now, you can see that the angle is, I think you see this angle here. Then, meaning if that is 45, then this angle here is going to be 45. This is 45, then this is going to be 45. Remember, I'm having this. If this is 45, this is 45, this is 45, and this is going to be 45. So, that is the case I'm having there. So, if this is 45 degrees, then it means that if you resolve this, this is going to be F, you see, it's going to be opposite to that angle. So sine 45, and then this one is going to be F cos 45, because it's adjacent to that angle. So after resolving those ones, those are the only things you need to know. So always, what do you note? This angle here is always equal to this angle. This angle here, this angle is always equal to this angle. So this is always equal to that angle there. See? But the idea is, if this is 45, then the whole from here up to here is 90, because always the action is perpendicular. So get 90 minus the angle you have here, you get a balance. And also this one, with the vertical and horizontal, they will be having 90. So if you have this, you can get this. That's the idea. Anyway, so there, now we are going to resolve, let us resolve vertical. Let us start by resolving vertical. Resolve vertical, we have this force and that force. But first of all, they gave us that our mu is 0.5. But what do we know? We know that always our frictional force is equal to mu r. So our F is going to be 0.4 r, which we shall substitute in there. So resolving upwards, we have this, and this, all of them are going upwards. So we have r sine 45, then plus F sine 45 equaling to, instead the only force acting downwards is the weight, which is 700 D. As simple as that. Okay, so now we know what F is from there, and then we R. So this is going to be having R times sine 45 is 1 over root 2. Then plus our F is 0.4 R times 1 over root 2 equaling to 700 times 9.8. So you see when I add, this is coefficient 1 and this is 1, so I'm going to be adding 1.4 R the whole over root 2. It's going to be equaling to 2. When you simplify that on Carol, getting 686. So when you simplify that and we divide, our R from here is going to be 4900 root 2 Newton. So that's our reaction. They want us to get between the car and then the rod. Then part B, they want us to get our frictional force. So that our frictional force is the mu R, which is 0.4 times our R, which is 4900 root 2. So from here, my frictional force is going to be 1960 root 2 newtons. You can give it 4 decimal places, but may want to give it there. Then C, they want us to get the V. Remember, this is minimum speed, that's our Y, our weight, our friction is acting in that sense. Okay, so there, that means that now V, means that now, how do we bring in V? We bring in V when we bring in the centripetal force. That means we are going to resolve horizontally. So resolving horizontally, our forces are going inside and this one is going inside. So if we resolve in this order, then let me resolve in this order there. Okay, resolving in that order, we have this, then minus this. So, or we can say, let us resolve in the other order based on the reaction. Basing on the reaction, if we resolve in this order, I can have now r cos 45. So this one is opposing, so then minus f cos 45. The whole of this is going to be equal to 2. It's going to be equal to 2. Now, any horizontal components, they are going to be equal to the centripetal force that is pulling this towards the center of the path. So all of them should be equal to this, because these ones are pulling into this. So all those components should be equal to the centripetal force towards the center of the path. So our centripetal force is always m v squared over r, and we want this v. So our r is here as 4900 root 2 times cos 45. From here, I gave you this, those are special angles, then minus f, which is 196 times 1 over root 2, equal to my mass, which is 700 times v squared, which you are looking for, divided by 50. So now, you see this one, it's going to simplify this. Then this one I'm also forgetting root 2, which I can ably put there. I don't know why I always forget root 2. Okay, this is 1960 root 2. This was there, it is going to simplify. Then when you simplify that, we get 2940 equal to 2. You see this one is going to cancel. By 5 there, we get 25. 25 v squared. Okay. Sorry, this is 14. It's 14. 14, so our v squared here is going to be, okay, our v, let me just do that one step v. We are going to take the square roots. So here our v is going to be this, 2940 divided by 14, then you get a square root. So that is going to be 2940 divided by 14. So this will give us a root of 210. Do you have anything serious? Any square number? Let me see. 70. Nope. Let me see 5. No, so that means we are just going to put it at that. So our v is going to be root 110 meters per second. So that is going to be our answer, which you can then give as 14.914 meters per second. Okay, then but they want us to get the angular speed. You know that our v is equal to a radius times the angular velocity. So if you want this, the angular speed, omega is going to be v over r. So our v, which is root 210 over our radius. What's our radius? Our radius was 50. Now this is in rad per second. Remember, they want us to give it in revolution per second. But we know that that's 2 pi. Know that 2 pi rad is equal to 1 revolution. So meaning 1 rad is equal to 1 over 2 pi revolution. meaning to convert this, all we are going to do, we are going to multiply with 100, multiply it with this. So now our and it's going to be now root 210 over 350, then times 1 over 2 pi. Now this is the rev per second. But you know that every per second, you know that this is what you know. Is that 1 minute is equal to 60 seconds. What about every per second? So every, if we divide the side, we have 1 over 60 mean equal to 1 second. So get the reciprocal this side and this side. So this will be 60, the reciprocal of this. Then this will be per mean. Then the reciprocal of mean is per mean. The reciprocal of s is per second. So convert this now to a mean. We are going to multiply this with 60. So now my angular velocity is going to be now root 210 over 350, okay, over 100 pi. Let me note over 100 pi. Then times 1 per second is equal to 60 per minute. 60. Then this is rev per minute. And so that's going to be our answer, which is going to be simplified to anyway, we can leave it there. So it is going to be simplified to this is going to be 60, so this 60 is going to cancel, then by 3, so it's going to be 3 over 5 root 210 rev per minute. So that is going to be the answer there. So that's it. I wish you well. Whenever you always take the rules, they want you to convert to. So see you there.